Hey everybody, we're here for day 7 of Advent of Code 2015. Again, we're just trying to solve it, see if we can't get our solving muscles bigger, better, faster. Faster is an interesting one. I don't know if I've solved any of these particularly fast, but although that might be fun to try solve them fast. Anyway, we'll see. But we're here today doing day 7 of year 2015. Again, love to see your comments or any thoughts or things you have about different days, how to do them better or how to do them differently. So with that being said, we'll start with day 7, some assembly required. So this year, Santa brought little Bobby tables, a set of wires, and bitwise logic gates. Little Bobby tables, that's funny. I think that's a reference to an XKCD where the kid's name was Bobby Tables because it had like a SQL injection in his name and it was ruining the school or whatever. Okay. Unfortunately, little Bobby is a little under the recommended age range and he needs help assembling the circuit. Each wire has an identifier, some lowercase numbers, and can carry a 16-bit signal, a number from 0, so a U16. A signal is provided to each wire by a gate, another wire, or some specific value. Each wire can only get a signal from one source, but can provide its signal to multiple destinations. A gate provides no signal until all of its inputs have a signal. The included instruction booklet describes how to connect the parts together. A and Y to Z means, or X and Y to Z means connect wires X and Y to an AND gate and then connect its output to wire Z. For example, 1, 2, 3 to X means that the signal 1, 2, 3 is provided to wire X. X and Y to Z means the bitwise AND of wires X and Y is provided to the wire Z. PL shift 2 means that the value of P is left shifted by 2 and then provided to wire Q. Not EF, not E to F means bitwise complement of the value from wire E is provided to wire F. Other possible gates include OR, R and R shift. If for some reason you'd like to emulate the circuit instead, almost all programming languages, for example C, Python, provide operators for these gates. Yeah, it's just saying what are the operators like bitwise and L shift, R shift, OR, and complement. For example, here's a simple circuit. 1, 2, 3 goes to X, 4, 5, 6 goes to Y, X and Y goes to D, X or Y goes to E, X L shift 2 F, Y R shift 2 G, not X to H, not Y to I. After this run, these are the signals on the wire. D, E. So it has all these values. In Lil Bobby's kit instruction booklet, provided as your puzzle input, what signal is ultimately provided to wire A? Okay, this one doesn't have an A. That's funny. So what's going through my mind is like, how do we want to solve this? Each wire can only get a signal from one source, but can provide a signal to multiple destinations. Okay, so that means like what's that saying is when you've seen an X on this side, there'll never be another X, right? On this side. Like the right-hand side of these equations are unique. Like that might be confusing because you might say 1, 2, 3 to X and then 4, 5, 6 to X. You say, okay, well, what do I do with that? And so that's just saying it's never going to overlap. But it can provide, so like X can be used all over the place over here, right? Connect wires X and Y, output to Z. Each wire can only get a signal from one source. A gate provides no signal until all of its inputs have a signal, right? So like in the middle of processing, you could never ask like, you wouldn't run this until this had happened. Like these values have to have been used up here. So like that's kind of like a like, okay, so this is all me to say, like I think there's probably at least 2 ways to solve this. The first way is you could actually turn this into a graph, right? So imagine this being graphed as you have 1, 2, 3 going into X, 4, 5, 6 going into Y, and then X and Y being sent in the diagram, their AND being sent to D and their OR being sent to E. So you could potentially build a graph where these are the values, or sorry, these are the keys. The right hand side is the keys, and then these are the left hand side is the values that say here's how I get to that key. And then you could like recursively go through the hash to solve it. Essentially what you're saying is, can I create a graph and then do it? Another way is just to like, I mean, I was going to say sort these so that sort these such that like this one can't happen until this one. And so if you sorted them all in that order, you could just run through these one at a time, and then eventually you'd get there. You'd eventually, at least in our case, we'd find a wire A that says, hey, here's A, here's what A is, and then you'd be done. Does that make sense? So you're basically like looping through these till you get them done. You technically don't have to sort them though. You could also just say, I'm going to go through the list and find which ones I do have values for and solve them, and then take those out of my list and then find, and then go through the rest of the list and say which ones don't have values for, and then try and solve them. And you just do that over and over until you have none left in your list that are unsolved. I don't know which way is better. Or how many instructions there are. Maybe that's worth looking at. I did open it up over here. How many instructions do we have? 339. So it's not a lot. Like what I was going to say is like, if all of these are like, so here's what the graph would look like, right? We'd obviously want to find A, and we know A goes to LX. So we just want to search for LX. It goes to LW or LV. So we're now going to search for LW, and that has LC, and LV has LU. You're going to go through all these like recursively to try and solve each of those, and then boil it back up. If that makes sense. Either way, we have to parse the values, so maybe we just start with that. I'm inclined to use Rust to parse these because there's enough of them that I'd want to be able to parse them all and kind of do some. I think the parser would help. That being said, I'm not super familiar with nom, so I may ask the AI to help me here a little bit. So let's just open that up and we'll start doing this and see how we get. Well, okay, so first we know we want an operand, so we'll have a enum operand, and it's either going to be a value of U16 or it's going to be a variable of a string. What am I doing wrong? Oh, I don't have the slide. Okay, so we just need to. Presumably these strings hang around the whole time, so that's like, okay, we can worry about. We can just make this a string if we have to. Let's just see what it says. Alt map. Is nom U16 really one? Okay, I just need to include all this stuff. Yeah, I don't know where it's getting this one. Oops. What am I missing here? Like that. And oh, I'm missing it here. You had to put it in so many places, but I think. Okay. So that feels right. This does not feel right. I have no idea. I kind of want to use like another thing to try and. What is nom16? I've never seen this before. In nom numbers complete. it not going to be able to fix this? It doesn't feel like it's getting better, right? The function found choice full name has type. Let's just see what Claude says about it. I think what it's saying is which I don't understand, is like it can't get from here to here. How's that the fix? This is where it feels like AI is not helping. I'm sorry, I'm just not very familiar with nom. Usually when I do it, I like can spend a lot of time. The issue. I don't think it's that either. So do I have to just? Will AI ever get it? Probably not. Maybe I should just use Gemini or something. We'll try another one. Oh, I need to include parser. Is this something that's changed in nom? I don't remember having to do this. Okay, so there's an operand. AI sort of helped, not really. But so now we get either of these. And this. This side should always be an operand variable. What are these called? another set of instructions. So we have like a set, which is an operand and an operand. Like we set A to B, or first to second. And then we have a and, which is this. And so we have and, or, L shift, R shift, which are the same as this. And then we have a not, which is like this one. Right? So we have a set, which is this to this, and which is this and this go to this and this go to this, or which is the same but with or. Then you have L shift, R shift, which are the same, and then not, which is a complement. So not this to this. Can I be this explicit? Like I always know this last one is this, right? I'm inclined to leave it like that because we know it's always going to be a value. And so we should parse it that way. But these other sides we don't know. I actually don't even know how. To parse these. Like it's got to be some kind of, like we probably want to look for keywords. There is some help that we know that, like, you know, knots always start with knots. It's like you could almost parse these first. It's just mad because I haven't returned it. Okay, well, I'm inclined to let AI do this. My thinking is like you probably do the not first. Let's just see what it does. Like my thing is like these mappings. The mappings would work because you'd look for not something blah, not something blah, that and that or that R shift, that L shift. Yeah, it's just doing these. Yeah, okay. So I did get there. What doesn't it like about tuple? Okay. You just use them directly. I think those are just dead codes. But so what is it doing? We're picking one of those, right? We're saying, can we find a not? Can we find an L shift, an R shift, an and, an or a set? Okay, let's try that. I feel a little icky having AI help me with that because I actually think I figured it out in the end, but I'm just not new enough to nom. Oops, what happened there? Like that? Because nom always returns what's left over. So let's just for instructions. Okay, I'm gonna have to impl debug and all that stuff, right? Like that's what it's mad about. Okay, I think it's just mad that I'm not using any of those. Okay, so the last one is not HNHO, and the first one is BN R shift BN to BO. Okay. Ooh, do I want to? Because I kind of want, like, what I want to do actually is include, like, I don't want this to be the value here. I want the set to just be like the operands, and then the value to be a separate thing. So this is something where AI could definitely help. Could you modify instruction and its parse method? I'd like to return a tuple of the instruction and the variable from the end, and then the instructions shouldn't have the variable at the end. That way I can use a hash map. Let's see if it'll do it. This is the busy work that I like AI doing. Assuming it can actually do it. Looks like it's doing it. I don't want you to run anything. HNHO at the end again. Yeah, perfect. This is what I actually want, and here's the reason why. So what I actually think I want to do is store these in a hash map, because what my goal is to like recursively descend to say, oh, in order to do A, I need to run this instruction. What are the variables in that instruction? And then I need to find those values to do that. And I'm just going to do that recursively and then bubble back up. Like that's my goal. So it took me 30 minutes to get to that or whatever, doing all the parsing and using AI, but I think we got there. So let's try it now. Uh, I need to switch these around. Okay, let's try it one more time. Yeah, so now do you see how it's got like the values on the left-hand side and then what I need to do on the right-hand side? So now I can do something like this. I can say Let A equal instructions A. And now we just need to implement solve P1. I can just do it like this, I guess. It's an I'm sorry, it's a U16, right? Okay. So again, we're going to solve this recursively. So we want to find this variable. So let op equal instructions variable. We're just going to assume we will always get it for now. And then we'll match op. And I need to implement all of these. I guess it's called, it's not. We need to map all of these. Ooh, I need to change all of these too, right? To actual values. Ooh, I need to track the values. Do I? Oh, am I going about this the wrong way? GN will always come from something which I will be parsing it twice. There'll never be a case I could be parsing things twice, right? Like, how do I say this? Maybe it shows up in one of these. Yeah, like the way to think about it is when I'm parsing D, I'm looking for X and Y. And so I go find X and it's this, and I go find Y and it's this. When I'm doing E, I'm doing X or Y. I'm going to go find X and I'm going to go find Y, and I'm going to put them here. So I am parsing them twice. That's a little inefficient, but who cares? We'll I think for now we just go like this. Oh, these need to be... how do you do this in VS Code? Okay, so for each of these, I need to... Why is it still mad at this right here? Did I do something weird here? Oh, I did. I messed this up. I was thinking I might need to keep track of the values. If you're just like iterating through them, you might. This is going to check some of them twice. So if the diagram is very complex and it reuses a lot of variables a lot, this could be inefficient. But let's just I just want to try and solve it right now. So if it's set L, we just need to, this is just match L, and it's going to be if it's a value, we just return A. If it's operand variable A, then we return solve P1 instructions A. Dereference. Oh, this should be this. So does that make sense what I'm doing? I'm just doing this recursively, right? I'm gonna start at A, and then I'm gonna do the set. So if it's set and it's a value, I just give it right back. Otherwise, I need to recursively find out what this is right here and solve it. So A is probably a... like that, maybe? Not is going to be the same, except I'm going to return the complement of it. Is that what it said? Not is a bitwise complement. I actually don't know. So I mean, I presume or is or and is and. It's literally a not. Okay. Like that. Okay, so these ones are more complicated in that what I need to do is do these two things. So we'll say like let L equals, and it's going to be this match statement right here. And then we need to do R as well. And then we just return, in this one, it's L and R, presumably. So I think I need to do this with the rest of these, the or, so and or, L shift, R shift. So this is or, and it will be or, R shift. It's going to be this. L shift is going to be this. Okay, so that's a little bit of work. It looks very terse. There might be a better way to like figure to do this. But and goes to and, or goes to or. R shift goes this way, L shift goes this way. Let me just make sure I have those right. L shift this way, R shift this way. R shift this way. Okay, so presumably that solves it. It's taking a lot of time. This, again, this may be very inefficient because it may have to... Or I have some loop. So I'm trying to find A in the variable, and then I'm going to get its instruction on how to solve for A. And A is going to do this. So I could keep track of a... Like if I've solved it, there's no need to solve it again, I guess is what I'm saying. What am I doing here? It's like a memo. Missing this here. No? Oh. So all of these should have the memo in them. Okay, but we aren't actually setting the memo. So we need to I guess we just do it like this. Let result equal match. And then we'll say memo dot set variable result. Oh, is it put? Insert. Okay. Still not happy. Oh, the life. We gotta do the lifetimes. More lifetimes. Is that better? Okay, let's see if that solves it faster. I'm worried I've still got a bug. No, there we go. Okay, much faster. So what is the issue? Again, like I had mentioned before, essentially what I'm doing is building a graph, but I wasn't keeping track of like where I'm. You can think about what I'm doing is I'm using a graph to like recursively solve backwards to get to A. But what I wasn't doing was saying, oh, let's keep track of things I've already solved for, right? So somewhere in here is an A, and no, not that one. It's right here, goes to LX or whatever. But like, I don't know, this one right here, LF or LQ. Once I've solved for LQ, surely this is used in other places, right? It's used in at least one other place. There's no need to solve it again, but there's probably a bunch of these, right? Like LL is only used twice. I don't know. Some of them are used multiple places, would be my guess. And so it was taking a long time. I mean, let's see if we got it right, first of all. Don't count your chickens before they hatch. That is the right answer. Okay, we got there. Again, it's quite possible that it would be faster just to like keep a list of all the instructions and keep which ones you've solved. Keep the values of the ones you've solved and just go through them and solve them and then remove those from your list until you've removed them all and then just search for A. But I think this one works and it works recursively. It's a little ugly. We maybe definitely try and clean it up, although we've been going for almost an hour now. So now take the signal you got on wire A, override wire B to that signal, and reset the other wires, including A. What new signal is ultimately provided for wire A? Now take the signal you got on wire A, override wire B to that signal, and reset the other wires, including A. What's the new one? So, I mean, this is going to feel hacky, but it does feel like what we do here is, we'll just copy and paste here. And we'll say, let A equal this. And so now we start over though. So we want a new memo. but we want memo.insert B to be A. And then we want to just do this. So you're running it twice. That's the right answer. Okay, so what is the solution? Part 2. This is very, I'm doubling a lot of the work, but again, both of them don't take actually very long once you've solved them. I do part 2. Oh, do you know, actually, so I could simplify this, but we'll simplify in a second. Basically, I take the answer from part 1 and run it, and then I create a new memo, like a new memoization hash, and then I set B to A, and then I just run it again to solve for A. So this we can actually change to, let's see, I don't know, DFS. That's not a good name either. Like solve circuit. It's not just solve P1 anymore. And this one we could just say A equals P1 input. Actually, I want to keep the instructions. So A equals P1 input unwrap. What the heck was that? Okay, so we solve P1, get its results, and put them in here for P2. Do that. Okay, I'd be interested to see how other people solve this way. Solved it. Again, this is really fast solving, so it doesn't feel like I've done anything like super inefficient. So let's just look really quick. What can we clean up? You can definitely commenting would help a lot, but like this, I think this is okay. Even though I mean I did get it from the AI, but like we just say, okay, can we turn it into a U16, or if not, can we turn it into an alpha? These ones, again, I think I think using num is great. I just haven't used it in a while, so I don't have the familiarity. So I think it's okay to do this. And again, so what do? I just parse all the instructions, map them to their instruction, right? And then create a hash map. So I have like the graph of like where each node goes, how each node talks to the other nodes in the circuit. Like if you think about a circuit diagram, this would like allow you to build the graph of the circuit diagram. And then I just call the solve circuit on it. For part 2, I do the same thing. I take the output of part 1. Oh, do you know what? I could change this up a little bit if I really wanted to be efficient. Like I've already solved part 1 here. Like I could say this requires a value for B. I don't have to do this again. I'm still, in a lot of places, I'm parsing the instructions multiple times. But that probably, oops, what is it not like? Huh? Oh. Yeah, this solves it faster because it's already like done the part of the A in part 1. So anyway, it modifies my solve, but because A goes into B, or sorry, part 2 uses part 1. Maybe the way to say that is I can do this to optimize it a little bit and maybe make it cleaner. Like it's obvious that part 2 is related to part 1. So maybe we can actually change this to be like E1 and then something like that. So it's more clear. Ugh, this part is really ugly. They all look identical. That's funny, except for this one. I could change this one to work like that, though. So I could do something to clean it up and say, like, we do like a let what would the function name be? Like operand helper equals we'd need instructions memo instruction does it want me to do maybe like this? Mismatch type expected operand blah found operand blah. I thought I could just dereference, right? Is that Oh, do I need to implement the copy tray? That. Okay, that's why it was mad. Just I didn't have the copy. So these all potentially change to now. Like this. This feels like an AI thing. We need to double check. I think all of them are okay, but the one that we definitely need to fix is this one. Oh, it did it. Okay, so okay, do I get the same answer? Yes. Okay. I don't think I Oh, I realize you can't see what I'm asking the AI. That's weird. Oh, it's up here. Because I'm just wondering, like, do I need to have these in there? I can probably just say solve the circuit, and then instructions and memo are included in there. We'll see. What is it changing? I was trying to do them one at a time. It's got okay. I can't do that because of the borrowing issues. Okay, so this is fine. This works. It's just so I think this is cleaner to read. We can say, hey, I have this little helper function that will say, here's how you like solve for the operands. We could use a macro, right? Maybe that's easier. I've used macros before, I think, but like the idea is it's going to look like a function, but it's actually a macro. And so it gets rid of like the borrowing issues and stuff like that. And presumably it solves in the same. Yeah. Maybe a little slower. So like the idea is we're doing the same thing. We're just creating a macro to do it. And what happens is the compiler is going to expand this beforehand. So the code feels more readable, at least from my perspective it does. Let's get AI to do one more thing. Do we need L val, and R val? Can we just do the macros directly? Like I'm wondering if you just can't do eval operand and eval operand. Yep, like this. And that feels like even more cleaner. Okay, this feels much cleaner to me. So I know I've spent a lot of time going over this, but I think the iterating is good. And I think these last few things, this is where AI is really good, is like it's much easier just to tell the AI, hey, can you do this? And see if it can do it. You'd potentially use, like Vim macros or whatever to help you do it. But there we go. So what does the solve circuit do? Again, we create this macro. We've got our list of instructions, right? And we create our macro, and then we just say what is each, how do I get this variable? How do I solve for this variable that you're asking me to solve for? And the top one is A, so it'll go and find how you solve for A, and it'll say, oh, in order to solve for A, I need to know B and C or whatever, right? It was like LW, LV or whatever. And it'll do that recursively. But what it's basically doing is just for each of those saying, okay, like let's match the instruction. And if it's a set, I know I can just do the eval operand. Otherwise, I do the different instructions, right? L and R, L or R, L, R shift R, L shift R, not L, right? I'm just doing the instructions. Then I save it and return the result. The reason I want to save it is because I don't want to like keep going down parts of the graph. If I've already solved some, maybe not. Maybe the way to say this is like it's less of. I mean, it is still a graph. Everything's a graph, right? If you're still listening, ha ha ha, funny. But it's a abstract syntax tree is the way to think about it. The circuit is essentially an abstract syntax tree, right? And so like you can think about like this is like a programming language that says to answer this, I need to solve this. To answer this, I need to solve this, and so on and so forth. And it does that recursive. So we've created this whole syntax tree. But the weird thing about the tree is like sometimes you get nodes in the tree that both their solution comes from the same value that you've already solved before. There's no need to solve that again. So if we've already solved one of these, if we see AR multiple times on this left-hand side, we only have to solve it once. Once we've solved AR once, we've solved them all. And so that's what the memo allows us to do, is we can look it up and say, hey, have we already figured out this part of the tree? And if we've already figured out that part of the tree, there's no reason to continue. There you go. This one's I'm very much interested to see how other people solved it. What's funny now is like after using these macros and stuff like that, the actual solution looks relatively simple. Isn't that the case though with graphs or recursion anyway? Like once you've kind of like done all the dirty work of building the graph up. Like the solutions to it are like really simple. I think we've shown before cases where it's like where we're doing like DFS or Dijkstra's. You can it's like 15, 20 lines of code, right? And it feels like magic. But anyway, the hardest part in this one, well, I had some bugs I had to figure out, which was probably most of the time. But I probably spent most of the time trying to figure this part out using nom. If you have a solution that doesn't use nom, I'd be interested to compare and contrast. This feels like a lot, although it is a little verbose, right? Just because of the way that it's parsed it, or it's indented it. Anyway, I'd love to see how you do it. So this one's taken a lot longer. I think, again, it was mostly just the parsing part of it. The actual solving, especially part 2, was super easy. But we figured it out. We got there. I definitely think this is reasonable. So I'll post my solution, and I'd love to see yours. With that being said, hope you're doing well wherever, whenever you are. And we'll talk to you next time.